Okay, we have already talked about this word in math class, a radical. That is that symbol. That symbol is the radical symbol. So, a radical in math class is any expression using that symbol, which you, of course, all recognize is the Van's symbol, which is actually where it comes from, the square root of the answer. But that's trivia for another day. If you see this symbol, doesn't matter what else you see, if you see this, you are going to be dealing with radicals and following these rules. Okay? Always. An entire radical. What does entire mean in English? Whole. If it is an entire radical, it is that symbol with something under there. Something under there. Thank you. This isn't a hard job. You guys just got to do the gags. This is what is called a radicand. Know that word. I will use it constantly. I will not call it the numbers that live under the roof of the square root sign, because that's not what it's called. It is a radicand. Okay? All right. A mixed radical has a radical symbol because it always does. It has a radicand because it always does. But it also has this, which is a coefficient. And what does a coefficient do to the right thing right beside it? Multiplies it. This says you are taking the y value times the radical, the root of x. Everybody cool? This is read as root x. If there was a little 3 there, cube root x, or the third root of x. If there was a 4 there, fourth root of x. If there was a 5 there, the fifth root of x. Does everybody understand? All right. Now, we are going to learn how to deal with these properly. Some of you may already know. I apologize, of course, if you have seen it before. First of all, we have already done the square root of 72, right? It didn't exist. So it's irrational, yes? We guessed it by saying, oh, it's between 8 and 9. It's about halfway between 8 and 9. So we guessed it at 8.5, punched into our calculator, got 8.48, yes? 8.48, except in physics and physics, this is the wrong answer to this. We, math guys, do not want to see this ever again. Does everybody understand? You will not be square root of an irrational, or you will not be using your calculator to evaluate irrational numbers ever again. Now, that's not totally true because you never say never. But in this room, if you see this and it's not perfect, do not touch your calculator's square root button. Do you all hear me? Yeah. It has been recorded. I have said it. You have all agreed. I am going to give you a test on this stuff. On that test, there will be square root signs that are irrational. And some of you, even though I am saying this, will write that as an answer and then get mad at me when I give you 0. Do you all understand? You will never do this for me. All right. Never. here is what you do. Now, the reason I gave you that thing yesterday and the reason I made such a big deal, don't write this down, but the reason I made a big deal of showing you this pattern, the square root of 100 was 10 and the square root of 400 was 20, because that is the square root of 4 times 100, which is the square root of 4, and the square root of 100, which is 2 times 10, which is 20. Remember when we talked about that? And then we used that knowledge on this page to do some pretty hefty work with big numbers, yes? We split it down. What do we call it when we take a number and we break it down into two other numbers that multiply together? We made factors, didn't we? So, how do we deal with this that doesn't work nicely for us? We will make factors. Now, I am going to show you the longest possible way to do this that will always work. All right? If you stop listening to me and you say, nope, I'm going to do it that way for the rest of my life, it will always work. You can develop shortcuts in a moment, but first you see all of it. All right? So, first we have to make sure we are aware of what this is asking us. I have not drawn an index number here, correct? What number is it? What number should go there? Do you think? 2. We don't write it because there is no smaller value that could go there than 2. Because a square root seeks the 2 equal factors, yes? Can you have one factor of something? No, because it's not a factor until it multiplies by something else. So just like we don't write the exponent of 1, we don't write the index of 2. But it is technically there. Everybody cool? Now, since this does not work, we are going to break it down just like we broke down 27,000. How do we break it down? You already know we're going to do prime factors. Okay? That's why we reviewed factor trees yesterday. So you take 72, and however you see fit, you break that down. What would your first two factors be? Don't yell it out loud. Just write it down. Because I like to do a funny joke here. Obviously, your first line there is 24 and 3, right? Of course not. Obviously, it's 12 and 6. Of course not. I would bet good money that everybody has either 8 and 9 or 36 and 2. What do you got?
18 and 4.
18 and 4. Badass. Okay? The point I'm trying to make is, does it matter? No, because whatever I put there, I'm not stopping. And neither are you. Keep going until you can stop, which means you have a prime number at the end of every branch, just like yesterday, or the day before, or whenever we did it. I don't even remember. And what do you get?
3 squared times 2 cubed.
2 cubed times 3 squared. Everyone agree? So the square root of 72 is the exact same thing as the square root of 2 cubed times 3 squared. Yes? Right? Everyone agrees? Okay. Now, don't write down what I'm about to write down. What is the square root of 4?
2.
Why?
Because 2 times 2.
2 times 2 is 4. Everyone understands that, yes? So is the square root of 4 the exact same thing as the square root of 2 times 2? Yes, because 2 times 2 is 4, yes? Is 2 times 2 the exact same thing as the square root of 2 squared? And is the square root of 4 2? Okay, so if the square root of 4 is 2, and the square root of 4 is the square root of 2 squared, then what do we know about the square root of 2 squared and 2? They are equal. Is everybody with me, logically speaking now? Excellent. Now, you're smart kids. If something happens once in math, how often does it happen? Every time. That's why math is always so perfect and elegant and gorgeous. Because it doesn't come out one day and say, do I look fat in this? And if you answer them wrong, you're in trouble. Math doesn't do that. Math always knows it looks gorgeous. So you see 2 squared, and what came out from under the radical sign? A 2, yes? Everybody sees that, right? Okay. Well, over here you see a 3 squared, don't you? So what is coming out? A 3. Why? Because we are looking for groups of 2 factors. 3 squared means 2 factors, right? Now, being the intelligent young people that you are, you recognize that I have removed that 3 squared. What is left under there? Thank you. 2 cubed is still under there. How many groups of 2 can I remove when I have 2 cubed?
1.
This is where kids get in trouble. Because what? Because they don't listen to me when I start with exponents. What does 2 cubed mean?
2 times 2 times 2.
Right. So under the radical sign, there are now 3 2's, right? How many groups of 2 can I remove from a group of 3?
3. 2. 1.
Okay. Here are 3 felt pens. How many groups of 2 felt pens can I remove from my hand? 1. Okay?
I didn't understand the question.
Apparently not. And yet, when I changed it to felt pens instead of just numbers, you got it perfectly.
No, it totally made sense.
So, we will wait a moment for our projector to come back. And over the next couple of days, I will procure a cable to make this never happen again. So, this, you know, if you've been paying attention, that this is 2 times 2 times 2, isn't it? And there's a group of 2, isn't it? And anytime I have a group of 2, I can bring it out, can't I? So I'm going to write a 2 there, yes? Which now gives me this, doesn't it? Because now I have numbers in front. What do numbers in front become? They become coefficients. What do coefficients do? Multiply. What is 2 times 3? 6. And was I able to get everything out from under there? What stayed? A single 2. And that is what your answer is for the rest of your math days. How do we read that? 6 root 2. Does everyone understand? That is the longest way possible to do this question, these questions. We are going to do A and B the longest way possible. Then I'm going to let you in on a secret that will make your life much, much easier. Does 99 have a square root? Absolutely not. So we say to ourselves, self, I must break down 99. Go. Oh, man, getting me to do division in math class. Son of a bitch. I hate it when I have to do math in math class. It's like writing paragraphs in English or hitting a nail in woodwork. What is your first branches of 99 going to be?
33 and 3.
3 and 33. Great. What's 33 going to be?
11 and 3.
3 and 11. So, what do I have there really? I don't have the square root of 99. I have the square root of 3 squared times 11, don't I? Do you see a group of 2?
Yes.
Where?
On the inside.
3 squared. So what comes out here? 3, and what stays there? 11. Done. Everybody good? Spectacular. You do 75.
The whole thing?
Yep, whole thing. Because as soon as we get through 75, I'm going to give you a little trick that once again will make your life easier.
Is it just taking my 2s out of the fraction?
Could be. Sure. So, what's 75 break down into? 25 and 3. And 25 breaks down into 5 and 5. I know the screen just died. So the root of 75 is what? It is really the root of
5 squared
5 squared
times 3.
times 3. Are there any pairs there?
5 squared.
5 squared, so what comes out?
5.
What stays under there? 3. So the answer, 5 root 3. Does everybody understand? Right? The math tells you what to do. Once you make your factor tree, this little 2 tells you to find groups of 2. Right? Excellent. So now I said I would give you a gift. Right? That would make your life easier. Now remember, yesterday, when I suggested memorizing the perfect squares. Remember that? Okay. So, looking at the next one, I see that it is 80. 80 ends in 0, yes? What automatically are 2 numbers that will multiply in to all numbers ending in 0? 10 and 5. Is one of those a prime number? Which one? 5. So if I take 80 and I start my factor tree at 5, what do I get on the other branch? 16. Now, we are going to stop for a minute until my screen wakes up. Boop. Takes a long time for garbage to claw its way out of the bin. Thank you. If you are making a factor tree, I told you you have to stop only when every branch is a prime number, yes? That's a factor tree if that is our only job, to make a factor tree. However, in this question, we are using the factor tree as a tool to solve this radical, right? So we don't necessarily need to finish it. And we can stop it here because this is really the root of 16 times 5, correct? Does 16 have a square root? Yes. And if you have these memorized, you know that that is going to be 4 squared. And you know what's coming out? 4. And what stayed under there? 5. So if you can ever find perfect square factors, you can make your life a lot quicker, can't you? So let's look at 300. Is there a perfect square that goes into 300? 100. Isn't this the root of 3 times 100? What is the square root of 100? So what's coming out here? 10. What stayed under there? 3. Picking up what I'm putting down? Now, what if you're like, oh, Mr. Myers, I'm never going to memorize all those perfect squares. Does that matter? Of course not, because then you would just break it down the long way like we did for A and B. Everybody good? Yeah? So you do the last 3. Go. I should move my desk back to you guys because you're just laughing all the time. Something super funny. I want to be part of that. You don't need to apologize. I laugh all the time. Of course, I usually like to wait for my laughter till my work is done. Is it done? So no is the shorter answer than almost. In usual teenage fashion, you guys can't answer a yes-no question. Well, that's a tough one, isn't it? But I think you noticed that 3, 6, and 3 would all divide by what number? So what's 3 divided by 3? What's 6 divided by 3? What's 3 divided by 3? So you have 3 times 121, don't you? And isn't 121 a perfect square? Yeah. Booyah, Grandma. So, if I did the short way, my first step here would have been 9 times 7, yes? What's the square root of 9? 3. 3 root 7. If I had to go the long way, I went 63, 9, 7, prime number, 3, 3, prime numbers, square root of 3 squared times 7. There's my group of 2. Out comes a 3, and I leave a 7 under there. Do you get the same answer? It just takes a little bit longer. Right? When the numbers get big, often you will do a mix of the two. And you'll see some of that a little later on in our notes, okay? So 32 was what?
2 to 8.
I would have done 16 times 2. Why 16? Because 16 is a perfect square. What's the square root of 16? 4 root 2. Now, this is a tricky one, and I put this one here on purpose because a lot of you went 4 times 8, right? And then you said, oh, 4's got a square root, so you had 2 root 8, yeah? But isn't 8 2 times 4? There's another perfect square, so you got to bring out another 2. 2 times 2, 4, and I left that 2 under there. Okay?
Where would the 8 come from? Oh, if you did it the long way?
If you used 4 and 8. Most people would have stopped at 4 because they think, oh, 4 is a perfect square, I'm done.
Oh,
Right? Now, this one, if you do the long way, actually helps see a math thing. Because 32 breaks down into 2 to the 5th, right? So this is the root of 2 to the 5th. How many groups of 2 can I get out of 5? I can get 2 groups of 2, which counts for 4 of them. 2's out in front become 4, and I leave a 2 under there. I would like to reconnect. Actually, I would like to stay connected. That would be lovely. But don't worry, I care so much about you guys. I'm going to go and buy a $30 adapter so this never happens again. That's how much I care. Out of my own pocket. Can you believe it? It doesn't mean a damn thing to you, but it's important to me to do the best I can for my students, whether it's appreciated or not.
I do.
I know you do, Abby. I'm just giving you a hard time. So, what did you do with 363? That's the one I talked about with Abby. What did you do?
121 and 3.
That was 3 and 121. What is the square root of 121? So I get 11 root 3. And the computer wakes back up and allows you to see the glorious answers that you have all gotten on your own. Right?
Yes.
Spectacular. Turn the page over. Are those mixed or entire radicals? Mixed. Sometimes, and I know this seems weird, ladies and gentlemen, sometimes we want to go back the other way. And the reason for that is in future, we're going to be using these radicals in equations and things. So sometimes we want to go back the other way so we can work with them more efficiently when it becomes more complicated. Everybody cool? So, if I want this as an entire radical, that 2 that lives out front at some point must have lived where?
Under or in the radicand.
With the radicand, yes? If there is a single 2 out there, how big was the group that had to be under there? 2 of them. So this is really the root of 5 times 2 squared. What is 2 squared?
4.
So that is 5 times 4, so that is root 20. Everybody cool? Now you're intelligent. Oh, we'll wait a second on that. So what's this one? If there's a 7 out there, what was under there?
14.
No.
7 squared.
7 squared, which is 29 times 49, which I can't do in my head and I don't even care, because what matters is you know that it's 7 squared under there. Everybody cool? If there's a 6 out there, what was underneath?
36.
So 4 times 6 squared, which is 4 times 36, which is the root of 144, which is, of course, 12. Now, D is tricky. Remember, all math that you know always is in play. So,
On C, would you go down to 12?
no, because I wanted an entire radical. So you would write it as 144. In D, what is the coefficient?
-5 or 5.
5, because this is really -1 times 5, root 12, which means how many 5s are under there?
2.
5 squared, which is 12 times 25, which is 300. The negative continues to live out here. Does everyone understand me? Because there is no way to remove a negative from a square root. We all good? So, everybody should be comfortable with square roots, yes? I don't want you to write down what I'm about to do. I want you to look at it and think about it, okay? What is the square root of 32? We've already done that. You can all know it. Right? It's 16 times 2, so it's 4 root 2. Right? Everyone's good. I really don't want you writing stuff down right now. I want you thinking. Everybody can do that, right? If you were writing it down, you all could have done it, yeah? Because you know that 16 times 2 is 4 squared times 2, and you bring out the 4, yes? Okay. Now, I need you to apply all of your math knowledge. Okay? The radicand is going to change. It's going to be 32 x to the 4, y to the 6. Now what's the square root? Everybody think about it. Take a moment. You already know what to do here. What's this? That's 4 squared times 2, correct? And you brought out the group of 2, right? 4. That's okay. I'm going to write it on the board because I'm tired of this. It was square root of 32x 4 y 6, right? And we're all cool with this being 4 squared times 2, right? Okay. What then is that?
A perfect square.
Isn't that x squared?
Yeah.
And what's that?
Y cubed.
Isn't that y cubed? Okay. So, is there a group of 2?
Yes.
So what comes out here?
A 4.
4. Is there a group of 2?
Yes.
So what comes out?
X.
X. Is there a group of 2? So what comes out? X. Is there a group of 2?
Yes.
Yeah. And is there a group of 2?
Yes.
But really, this is y, isn't it? 6 y's. So is there a group of 2?
Yes.
So what comes out?
Y.
Is there a group of 2?
Yeah.
So what comes out?
Y.
Is there a group of 2?
Yeah.
So what comes out?
Y.
What did I leave under there?
Underwear.
2. And would we ever write this?
No.
How would we write this?
4 square y cubed root 2.
Everybody cool? That's the grade 11 radicals. The whole year. That. You're welcome. Everybody see how it works? Now, of course, there's a shortcut. I'm looking for groups of 2, aren't I? So I divide 4 into groups of 2 and I get x squared. I divide 6 into groups of 2 and I get y cubed. Easy peasy lemon squeezy, right? What if I changed it to this? Now what's the answer?
4x.
We know 4 is coming out.
X cubed.
Why is it x cubed?
Is there 7 in there?
Because there's 7 in there and I can get out 3 groups, right?
Yep. Y to the power 4.
Y to the 4th, because there's 9 in there and I can get out 4 groups. What did I leave under there?
2xy.
2, a single x, because I took out 6 of them, and
A single y.
a single y, because I took out 8 of them. Is everybody cool? This I might show on like a bonus question on a test or something, right? But you understand the principle. That's what I'm trying to get to across to you. Now let's see. Oh, the reconnection failed. That's awesome. Yeah, the bell is going to go. So, you are off the hook. I lie, you're not quite off the hook. Finish that page that we are on. Just that page. 6 questions on page 31.
Do you want them or
Not today. Bells rang. We'll get them tomorrow. I will get your quiz grades from you tomorrow. I will have a great rest of my day. You too.